Good morning, friends. We are discussing about the MCQ question asked in All India Medical Entrance Exam and also the NEET. Now, today we are going to discuss the MCQ question asked in 2005. The wave function of photosensitive surface is HF0 if source is incident with photon of 2 HF0 energy. That means whatever the photon are incident is having a double energy, 2 HF0. Then the maximum speed of the photoelectrons emitted is 4 into 10 raised to 6 meter per second. If the energy of photon is changed to pi HF0, then maximum speed of photoelectrons will be. That means we change the energy of the incident photon. Here initially the requirement is if the photon of energy HF0 is incident on a photosensitive surface, it produces the photoelectrons. Instead of the HF0, first we incident the photon with the energy is 2 HF0. At that time, what is the maximum speed of the photoelectrons emitted is 4 into 10 raised to 6 meter per second. Now, as we increase the energy of incident photon from 2 HF0 to pi HF0, so what should be the maximum speed of photoelectrons emitted? So we know that the Einstein's equation HF minus pi is equal to kinetic energy half m v square maximum. So using this equation HF minus pi is equal to half m v square maximum. So from this equation half m is constant, so we can write HF minus pi directly proportional to the v square maximum. So from this equation, as the energy is 2 HF0, at that time the speed is v1. Now listen, for energy is 2 HF0, at that time the maximum speed is v1. That is given. If the energy is pi HF0, at that time the speed is v2, we have to find out the value of v2. So from this equation we can write it this way, v2 square upon v1 square is equal to pi HF0 minus wave function is equal to HF0 upon 2 HF0 minus HF0. Therefore, v2 square upon v1 square is equal to 4. Take the square root on both sides. Therefore, v2 upon v1 is equal to 2. Therefore, maximum speed of the photoelectrons emitted is twice times of the v1. v1 is already given 4 into 10 raised to 6. Therefore, answer is 8 into 10 raised to 6 meter per second. That is our answer. Again, friends, we are using the equation, Einstein's equation for the photoelectric emission. Now, HF minus pi is equal to half m square maximum. Half m is constant, therefore, HF minus pi is directly proportional to the square maximum. Now, we have the energy of the photon is 2 HF0, at that time the maximum speed of the photoelectrons is v1, that is given 4 into 10 raised to 6. Now, if the energy of the photon incident is pi HF0, at that time what is the maximum speed of the photoelectrons? Therefore, pi HF0 at that time this maximum speed is v2, we have to find out the v2. So from this equation, pi HF0 minus HF0, because the wave function is equal to HF0. So proportional to the v2 square, and 2 HF0 minus HF0 is proportional to the v1 square. Taking the ratio of these two equations, v2 square upon v1 square is equal to pi HF0 minus HF0 upon 2 HF0 minus HF0. Therefore, 4 HF0 upon HF0, HF0 cancel, only we obtain v2 square upon v1 square is equal to 4. Now, taking square root on both sides, V2 upon V1 is equal to 2. Therefore, V2 is equal to 2V1. Now listen, value of V1 is already given 2 into 4 into 10 is to 6. Therefore, 8 into 10 is to 6 meter per second. Clear this? Okay. After that, the next question also asked in 2005. What is given? The work function of a metal A, B, and C are given. Therefore, work function for metal A, phi A is given as 1.92 electron volt. For B metal, that is given as the 2 electron volt, and for C metal, work function is given as the 5 electron volt. Now, according to the Einstein's equation, the radiation of 4100 angstrom wavelength is incident or produce the electrons for which metal of the given. Here the A, B, C or combination of any metal. For that purpose, we have to know that what is the minimum energy is required. E is equal to HF. E is equal to HF or Hc upon lambda. Here lambda we take in angstrom. Therefore, that is in electron volt. Substitute the value of Planck's constant 6.6 into 10 is to minus 34 C. 3 into 10 is to 8 upon 1.6 into 10 is to minus 19 lambda as it is in angstrom. Therefore, we obtain the 12375 upon lambda in angstrom, that is in electron volt. Now we substitute the value of wavelength lambda. Therefore, E is equal to 12375 upon 4100. Thus, we obtain E is equal to 3 electron volt. The metal which has the work function is more than this minimum energy, only those less than this energy, only the photoelectron emission is take place. Here, work function of A and B metals is less than 3 electron volt. So, electron emission produced in A and B. So, emission of electron will produce in A and B metal, B metals. Therefore, C option is right, or C option is right. Again, here the work function of the three metals are given. For metal A, 1.92 electron volt, for B, the 2 electron volt, and metal C, the 5 electron volt. That is the work function of particular metal. We know that if the energy of the incident is more than this work function, only those metal can produce the photoelectrons. So here, the wavelength of the incident light is given 4100 angstrom. So corresponding to this wavelength, first we have to find out the energy in electron volt. That means the incident energy on a metal in terms of electron volt, because the work function are given in electron volt. Therefore, E is equal to HF or E is equal to Hc upon lambda. So as we substitute the value, we find out the minimum energy minimum energy incident is 3 electron volt. Out of these 3 metal, which has the work function is less than this energy, it can produce the photoelectrons. So here, metal A and B has the work function is less than 3 electron volt. Therefore, the photoelectrons are emitted in metals A and B if the wavelength of light 4100 is incident on metal A and B, but the C can't produce the photoelectrons because the work function for metal C is 5 electron volt, but the incident energy is only 3 electron volt. Therefore, C can't produce the photo emission of electron. After that, next, the work function of aluminum plate is 5. When the radiation of HF energy is incident on metal surface, photoelectron of kinetic energy K is emitted. Now, if the frequency of radiation is made double, kinetic energy of the photoelectrons will become. So when the radiation having the frequency is HF or the HF energy is incident, at that time what is the photoelectrons are emitted having the kinetic energy is K. Now, the frequency of the radiation becomes the double. So what's happened? So what is the kinetic energy of the photoelectrons produced? For that purpose, again we are using the equation, Einstein's equation for photoelectric emission. Right? So this equation is that HF minus phi is equal to K. Kinetic energy. Right? So this equation phi is equal to HF minus K. Now we are using, that is our equation 1. The energy becomes the double. Therefore, instead of the HF, we make the 2HF energy. And kinetic energy of this produced is double. Therefore, 2HF is equal to phi plus energy. Substitute the value of phi in this. So what we obtain? The HF minus K plus K. K plus K. Therefore, K dash is equal to K plus HF. K plus HF. Therefore, the energy, kinetic energy of the photoelectrons becomes the K plus HF. That means there is the increase by the HF amount. Because the energy of the photon incident is now becomes the double from HF to 2HF. Therefore, the kinetic energy is also increased by HF value. Again, there is asked in 2006 where function of aluminum plate is phi. When radiation of HF energy is incident on metal surface, the photoelectrons of kinetic energy K is emitted. Now, if the frequency of radiation is double, the kinetic energy of the photoelectrons will become. For that purpose, we know that the Einstein's equation HF minus phi is equal to K. From this equation, phi is equal to HF minus K. Now, the energy of the radiation is double. Therefore, 2HF is equal to work function plus new energy K. We substitute the value of phi here. Therefore, 2HF is equal to HF minus K plus K. Take the HF and K this side. Therefore, 2HF minus HF plus K. So 2HF minus HF, HF is equal to plus K is equal to new kinetic energy K plus. Now the next, a laser emit the monochromatic light of 4 into 14 Hz frequency and produce the power of 2 into 10 is to minus 3 watt. Numbers of the photons produced per second will be. How many numbers of the photons are produced? So for that purpose, we know that the power or the energy radiated in unit time is equal to NHR. Therefore, N is equal to power upon HF. Here the power is given 2 into 10 is to minus 3. Upon H, Planck's constant 6.62 into 10 is to minus 34. Frequency is given 4 into 10 is to 40 Hz. Therefore, the number of photon incident produced per second will be 5 into 10 is to 15 per second. That is the number of photon produced per second. Again, here the laser emit the monochromatic light of frequency 4 into 10 is to 14 Hertz and produce the power of 2 into 10 is to minus 3 volt. So how many numbers of photons will produce per second? So we know that the power P is equal to NHF, but the energy per unit time, that is known as the power. E upon T is equal to P, is equal to NHF. Requires the number of photons produced per unit time. Therefore, P upon HF, so 5 into 10 is to 50. Now the next, asked in 2007, what is given? The light source emits the light of 5000 angstrom wavelength and power is 5 volt. When it is displaced by 0.5 meter away from the photo surface, the photoelectrons are emitted. When the distance increases by further 0.5 meter, the numbers of the photoelectrons liberated will become. Now listen, the number of photoelectrons numbers of the photoelectrons emitted is directly proportional to the intensity of incident light, and this intensity is directly proportional to the 1 upon R square. Therefore, 10E, number of photons, decrease by 1 by 4 times. Because the distance becomes the double, therefore 1 upon 2 square, that means there is the 1 by 4. Number of photoelectrons in E, directly inversely proportional to the 1 by 4. Therefore, the number of photons produced will be decreased by 1 by 4 times. Clear? Now friends, the next question asked in 2008. The work function of photosensitive surface is given 6.2 electron volt. If its stopping potential is 5 volt is given, then wavelength of incident radiation will be. We have to find out the wavelength, and according to this wavelength, whatever the light or of which region of electromagnetic waves, the light is incident to produce the photoelectrons. For that purpose, here the work function is given 6.2 electron volt. Therefore, phi is equal to 6.2 electron volt. Phi 0. Stopping potential is given, there is the 5 volt. We have to require the wavelength lambda. Now, friends, we know that Einstein's equation half mv square is equal to hf minus phi. Or in other words, half mv square maximum is equal to EV0. Therefore, we can write EV0 is equal to hf minus phi 0. Now we require the wavelength lambda. Therefore, hf is equal to EV0 plus phi 0. Instead of the frequency, that c upon lambda is equal to EV0 plus phi 0. Therefore, lambda is equal to hc upon EV0 plus phi 0. Now we substitute the value of hc and also stopping potential in phi 0. Therefore, lambda is equal to h 6.62 10 is to minus 34. C 3 into 10 is to 8 divided by EV0 in electron volt E 1.6, 10 is to minus 19, and stopping potential is given the phi plus phi 0 is given in electron volt, that is the 6.2 electron volt. Therefore, 6.2 into 10 is to my 6.2 into 1.6 into 10 is to minus 19. Then we simplify, we obtain the wavelength is 1.1 into 10 is to minus 7 meter. This wavelength lies in ultraviolet region. Therefore, the wavelength of incident radiation will be in ultraviolet region, UV region. That is our answer. Again, in photoelectric effect, the wave function of photosensitive surface 6.2 electron volt given and stopping potential is given 5 volt. We have to find out the wavelength, so we can find out the incident radiation is of which region of electromagnetic spectrum. For that purpose, we know that the EV0 is equal to HF minus phi 0. Therefore, HF is equal to EV0 plus phi 0. Now, instead of the frequency C by lambda, therefore HC upon lambda is equal to EV0 plus phi 0. We require the wavelength lambda, therefore lambda is equal to HC upon EV0 plus phi 0. At least substitute all the value. You obtain the wavelength is 1.1 into 10 is to minus 7 meter. That means 1100 angstrom. Therefore, that radiation lies in UV region of electromagnetic spectrum. After that, the next question asked in 2008, that is depends on the theory. Okay. Now, the color in discharge tube filled with a gas at low pressure is due to which of the following option? Yes, the atomic gas is filled in a tube, discharge tube at low pressure. The color are shown in this gas is due to which reason? First is the electron in excited state. Second, the collision between the atoms of gas. Third, collision between the charged particles emitted from the cathode and gas atoms. And D, collision between the electrons of atoms. Actually here, the color in discharge tube filled with a gas at low pressure is due to the electron get excited state and hence the colors are shown, or the colors is seen. So the result is that electron get excited state and hence color are seen in discharge tube. As the pressure is low, at that time the atom of the gas are excited and make the transition from ground state to the upper state or the excited state according to the energy. So as a result, during this transition in higher level state, it remain only 10 is to minus 9 second, and then make the retransition from high energy level to the ground state. So when the electron make the retransition from higher energy level to the ground state, at that time the exit energy is radiated. And corresponding to this energy radiated, what are the wavelength? So this type of the color is seen. Therefore, the result is that the electron get excited state and hence the color are seen in discharge tube. After that, the next asked in 2008, find velocity of the particle with 1 mg mass. So the mass m1 is given as the 1 mg. That means the 10 is to minus 3 gram. Right? That means the 10 is to minus 6 kg. Moving with the same wavelength, that wavelength is lambda 1. Of electron moving with the speed, mass of the electron Me is given 9.1 into 10 is to minus 31 kg. The speed of electron is given 3 into 10 is to 6 meter per second. Again, find velocity of the particle with 1 mg mass and having the same wavelength that of the electron moving with speed 3 into 10 is to 6 meter per second. Mass of the electron is 9.1 into 10 is to minus 31 kg. So here the wavelength of the particle and electron are same. Mass of the particle is given. We need to find out the velocity or the speed of this particle. Velocity of electron is given 3 into 10 raised to 6 meter per second. Mass is given and wavelength of electron is same as the wavelength of particle. Okay. Now for that we know that the wavelength lambda is equal to h upon p. Now lambda is equal to h upon p is equal to h upon mv. For particle lambda 1 is equal to h upon m1 into v1, and for electron lambda E is equal to h upon MeV. But both wavelengths are same. Lambda 1 is equal to lambda E. Therefore, h upon M1 V1 is equal to h upon MEV. H is cancelled. We require the V1. Therefore, MEV upon M1. MEV upon M1. If we substitute the value, mass of the electron 9.1, 10 is to minus 31. Velocity of the electron 3 into 10 is to 6. Now, mass of the particle 1 mg milligram, 10 is to minus 3 gram, therefore 10 is to minus 6 kg into 10 is to minus 6 kg. Therefore, we obtain the answer is 2.7 into 10 is to minus 21 meter per second. Very easy numerical. Using the equation of the Broglie wavelength, lambda is equal to h upon p. P is the momentum, is the mass into velocity. We are using this concept of the wavelength, lambda is equal to h upon p or h upon m. From this equation, for a particle, lambda 1 is equal to h upon m1 v1, and for electron, lambda E is equal to h upon MEV. But here the wavelength of both particle and electron are same, therefore lambda 1 is equal to lambda E. Substitute the value, h upon m1 v1 is equal to h upon MEV. Therefore we require the speed of particle v1 is equal to MEV upon m1. Any mass of electron 9.1, 10 is to minus 31. Velocity of a electron 3 into 10 is to 6 upon mass of a particle that is given 1 mg 1 milligram, therefore 10 is to minus 3 gram and 10 is to minus 6 kg. So as we simplify, we get the speed of a particle is 2.7 into 10 is to minus 21 meter per second. Now the next is asked in 2009. Number of photoelectrons emitted by the light with the frequency f is proportional to blank is here. Now, the number of the electrons depends on the intensity of the light. Here the frequency of the incident light is given more than the threshold frequency. So the incident light with the frequency f is more than threshold frequency always produce the photoelectric emission or the photoelectrons. But here, how many numbers of the photoelectrons produced, that is depends on the intensity. Already we discussed in characteristic of photoelectric effect by doing the graph of intensity versus the frequency. Right? For that purpose, the numbers of the photoelectrons is directly proportional to the intensity of incident light. For which condition? For f is greater than f0. If the frequency of the incident light must be greater than the threshold frequency, after that, how many numbers of the photoelectron produced, the photoelectric current obtained that is directly proportional to the intensity of incident light. As the intensity of incident light increases, so photoelectric current also increases. Clear? Okay. Now next, helium neon laser emit light of 667 nanometer and produce the pressure of 9 kilowatt. Number of the photon reaching to target per second will be. We have to find out the number of the photon electrons reaching or the incident on the photosensitive surface. So here the wavelength lambda is given the 667 nanometer. So it's equal to 667 into 10 is to minus 9 meter. And also the power P is given the 9 kilowatt. Now power is given 9 kilowatt, that means the 9 into 10 is to 3 watt. Now we require the number of the photon emitted per second. Therefore, power P is equal to NHF. But here the frequency is given, frequency is not given, wavelength is given, therefore NHC upon lambda. Now we require the wavelength lambda, therefore lambda is equal to wavelength lambda is equal to NHC. So we require the number of the photoelectrons produced, N is equal to P lambda upon NHC. Now we substitute the value power. Power is given 9 into 10 is to 3. Wavelength is given 667 into 10 is to minus 9. Planck's constant 6.6 into 10 is to minus 34 into C 3 into 10 is to 8. So as we simplify, we obtain the number of the photons produced per second is 3 into 10 is to 16 per second. Again, helium neon laser emit light of 667 nanometer and produce the power of 9 kilowatt. Number of the photoelectrons emitted by the reaching to the target every second will be. We know that the power P is equal to NHF. N is the number of photoelectrons emitted. Here, energy per unit time incident is known as the power. Therefore, power is equal to capital NHF. Capital N is equal to number of the photons incident in unit time. Therefore, frequency not given, we convert into wavelength. Therefore, NHC upon lambda. We require the number of the photons emitted per or the incident in 1 second. Therefore, N is equal to P lambda upon HC. Substitute the value P, 9 into 10 is to 3 power, and wavelength 667 into 10 is to minus 9. Value of H 6.610 is to minus 34, and C velocity of light 3 into 10 is to 8. So as a result, we obtain the number of the photons incident per second is 3 into 10 is to 16. Okay. After that, in a given region, electric and magnetic fields are perpendicular to each other. Electrons moving in this region do not get deflected. The charge on cathode will be. So here the electric and magnetic field are perpendicular to each other. When the electron beam is passing through this region, so not deflected by this field. Therefore, we can add the electron do not get deflected. Electron do not get deflected. It means the force due to the electric field and force due to the magnetic field are same. That means the EE is equal to EVB. Therefore, velocity is equal to E cancel E upon V. And also we know that the maximum kinetic energy and half mv square is equal to EV0 or the EV. And we substitute the value of v square or the E upon m. E upon M is equal to V square upon 2. Substitute the value of V, therefore E square upon 2VV square. That is the answer of E by M. So that is the charge on the cathode. E by M is equal to E square on 2VV square. Again, here the electron do not get deflected in the region in which the electric and magnetic field are perpendicular to each other. Therefore, the force due to the electric field and force due to the magnetic field on electron are same. Therefore, E is equal to BeV. E cancel. Therefore, speed of electron in both regions is E upon B. And also, the kinetic energy is equal to E into B. That means the charge on cathode. Therefore, E by M is equal to V square upon 2V, capital V. We substitute the velocity of the speed, we substitute the value of speed E by B, therefore E square upon B square into 2V. Therefore, the charge on cathode will be E square upon 2V B square.